Welcome to podcast 2-3, Pairs of Lines. There are 4 possibilities in which 2 lines can relate to each other, some of which you've heard, the first one being parallel. By definition, they do not intersect, they are coplanar. How do we draw that? To draw a coplanar, we're going to need to draw a plane. So the sketch of a plane, which we've already seen in lesson 1-1, this sort of 4-sided shape. Parallel lines are lines that are going to be on this plane. So, something like this. But what's to say that they do not intersect? Lines go forever. So we have a little bit of symbolism that's going to mean or imply that they do not intersect. And it's these tiny little triangles. So by drawing 2 lines with these little triangles on them, that would imply that they are parallel. Parallel lines, coplanar, do not intersect. Skew lines also do not intersect, but they're a 3-dimensional idea. They are non-coplanar. A little more unusual to draw. So again, we're going to draw the plane. And for them to be skew, that is not on the same plane, one line will be on the plane, but the other line will not. If you're not on the plane, it's possible to be through the plane. And this, as we saw in lesson 1-1, is how to draw a line through the plane. So here are 2 lines, one on and one through. They do not intersect, and they're non-coplanar. Skew. Let me show you this in one other way, and that's on the sketchpad activity, parallel versus skew. The green lines are parallel. As I drag that around, you'll see that they are on this grayish plane, and they do not intersect. I'm using them as segments just to help the look. So, the green lines, parallel. This red line is going through the plane, so it's skew to the green one, except for that one moment where I moved it. Now it's intersecting on the green ones. But here, the red line is skew to the green ones. So parallel versus skew is really a 2-dimensional idea versus a 3-dimensional idea. The next 2 also have very similar definitions, perpendicular and oblique. Both of these are intersecting lines, but as you already know, in perpendicular, those are lines that form a right angle. So here's a picture of a line intersecting another line, but did it form a right angle? To clarify that it is forming a right angle, we put the little box. If we see the box, that implies a right angle. Oblique lines are going to intersect, but they do not form a right angle. So, if we don't see that little box, we must assume that they're not forming a right angle. Intersecting lines that do not form a right angle, oblique. Now, how do they relate in terms of algebraic equations of lines? That is, lines that we can graph. We're not going to include skew for this, because skew is a 3-dimensional idea, and all the graphing you're doing to this point is 2-dimensional graphing, like on graph paper. So let's take an example of a line, y equals mx plus b form, or slope-intercept form. An example like y equals 2/3 x plus, and this number is irrelevant. It's all about the slope. To have an equation of a line parallel to this one, we would need that same slope. So how about if we use y equals, and the slope will have to be the same, 2/3, that is going in the same direction, and x, any number over here, like 2. These 2 lines would be parallel because they have equal slopes going in the same direction. If I wanted a line that is perpendicular to the given one, I'm not going to use 2/3. Perpendicular has to go in an opposite direction, you could say. That is, if one line's going down, the other line would have to be going up. So if this line is 2/3, this one's going to have to be negative, and we use the reciprocal 3/2. So this is an example of a line that is perpendicular to a given line. Reciprocal slopes, positive, negative. An oblique line example would just be anything that's not parallel and not perpendicular. So for oblique, use a slope that's not equal to and not a reciprocal of with the positive negative slope, like anything rather random. Well, that slope is not equal and it's not a reciprocal, therefore it's oblique. To look at the same idea graphically using the sketchpad activity, Here are two equations of lines. The red one and the blue one are parallel to each other because they have the same slopes. The software does not reduce the fraction, by the way, but they both have a slope of 4/6. If I change the red one, obviously now it's not parallel, it's not perpendicular. This would be called oblique. Their slopes are just different. But if I adjust this in just the correct way, is that perpendicular? Positive, negative, but they're not reciprocals. This is a right angle. I could even measure the angle. The measure of this angle CMB is exactly 90 degrees, and you can see that the slopes are reciprocals, positive, negative. So parallel lines have equal slopes, perpendicular lines have reciprocal slopes. Thus concludes podcast 2-3, Pairs of Lines.